Hello, and welcome to the info session for the Biomedical Engineering Instructional Laboratory, a teaching and lab space dedicated solely to undergraduate education in the Biomedical Engineering Department at RPI. I am Steve Kalista, Laboratory Manager, and I oversee the daily operations of the facility. Dr. Monica Agarwal, Lecturer, teaches the major laboratory course connected to this lab. As a team, we work closely with our students to train and develop proficiency with key biomedical engineering equipment housed in this space. This lab's equipment is the same research-grade equipment encountered in contemporary industry, academic, and government research laboratories. We constantly assess our equipment needs to ensure that our students have access to state-of-the-art contemporary research equipment. Students are trained to use this equipment through a dedicated laboratory course associated with this facility. They complete experiments adapted from those being conducted in active research labs across this campus. This laboratory course, BMED 4010, is a 4-credit course offered during all 3 academic terms, fall, spring, and the Arch, and is taken during the junior or senior year. The class is composed of lecture and laboratory content. The lecture and lab portions of the course move in tandem, where the lecture portion familiarizes students with concepts of lab safety, personal protective equipment, laboratory practice, and decorum, along with helping them develop strong scientific technical writing skills. The laboratory portion provides hands-on experience with equipment, where students will collect data to then analyze and discuss in laboratory reports. At the start of the course, students will choose a concentration area from the 3 major sections: biomaterials, biomechanics, or bioinstrumentation and bioimaging. After completing experiments common to all tracks in the first 2 weeks, including electrocardiography and separately spectrophotometry, cell counting, and pipetting exercises, students will then focus on a sequence of experiments within their specific concentration area. At the end of the first 6 weeks of laboratory experiments, students will become familiar with a major piece of equipment or set of experimental techniques particular to their area. They are then tasked with designing their own experiment within the scope of that concentration. Specifically, students are presented with a contemporary problem or research challenge, which can help in the development of a new biomedical product, surgical device, or technique. Over the next 6 to 7 weeks, or latter half of the course, students will examine the current scientific literature, conduct background research into the topic, develop a high-quality experimental technique to address this question through multiple meetings and written reports with their instructor, and ultimately come to the lab during a 2-week open testing period in which they can conduct these experiments on the equipment in an independent but supervised manner, both showing their mastery of new techniques and realizing how much they have developed their own laboratory skills. At the completion of the project, students will submit a journal article-style manuscript describing their research project and give a live group presentation in PowerPoint to their laboratory section. Given that this sort of technical communication is critical in the development of successful scientists and engineers who give these papers and presentations on a regular basis, this serves as excellent preparation to know what to expect as they move forward in their careers. To provide training on these activities, 2 lectures are given during the term to help them develop their technical writing skills and in developing and delivering high-quality presentation. Logistically, each 3-hour laboratory section is limited to 12 students, broken into 4 teams. Training and assisting students during the lab sessions are 3 to 4 individuals, including the lab manager, myself, instructor, Dr. Agarwal, and 1 to 2 graduate teaching assistants, or TAs. These TAs have received prior training on this specific equipment and often use these same techniques in their own research labs. The laboratory is composed of 2 main rooms, totaling approximately 1,500 square feet, between a cell culture space which includes multiple biosafety cabinets or hoods, microscopes, centrifuges, incubators, fridges, freezers, and more, and the large laboratory testing hall, with equipment catering to each of the 3 areas. An additional laboratory space of approximately 700 square feet remains accessible across the hall for an additional instruction and includes 2 chemical fume hoods and other equipment. After completion of the instructional course, we believe our students have developed both a fundamental understanding of the techniques being examined and the proficiency to be able to operate this equipment independently. After completion of this course, Many students are able to adapt these skills as they find opportunities working in research labs on campus, when placed in co-ops and internships away from RPI, and of course, in their future careers. Thank you for joining us today, and we hope to see you soon at Rensselaer.